So let's start the discussion again. Today I'm gonna continue with the MCQ discussion first, and then I think we can manage today as well as an essay question. Okay, so the previous week we had like finished the work for revision paper, finished revision paper 1. So today in this class, I think by now the students facing the exam physically and online have taken the exam. So this time slot we're gonna discuss the paper. Okay, I think all you have all of you have received the marking as well, so we will try to go through these questions quickly. So if you have any questions, I mean, when you are reading the marking, when you are reading through the marking, if you have encountered any question, now it's the time to ask it, so I can explain. Okay, so we'll continue then. So booster 1 MCQ. First one, first MCQ. And again, before starting the class, so this is the end of January. So I think those who have registered the class have, I mean, online students who have registered the class will receive their paper packs, I think, in a few days. So if you register and if you didn't get the paper pack, then you can inform me following, like, just look for it for a week and then inform me. Okay, so that's about the paper pack of this month. And again, so tomorrow we will be having the second recap session, which is focused on energy, then the equilibrium of forces and the center of gravity concepts, as well as the STVT curves. Okay, so there will be a recap session which covers these sections of mechanics. So if you want to get revise the topics, then you can join that session as well. Anyway, I know there are some students who watch the recording as well, but I mean, if you don't have this time slot free, you guys can watch the recording as well. Anyway, so the thing I expect from you guys is just to maintain the consistency as well as join the class, like follow the class material frequently within the week. Okay, so let's start the discussion. First one, dimensions of Young's modulus is. Okay, so the Young's modulus is defined if over A is equal to Y times E over L. And this is coming just from the Hooke's law. So if I substitute Y is F L divided by A E. So I want the dimensions. So the dimensions of Y should be the dimensions of force. Dimensions of force is ML T minus 2 times dimensions of length is L divided by dimensions of A, or the area, is L squared. Dimensions of E is nothing but the extension. Again, dimension is L. So you can see the dimensions of Young's modulus is ML minus 1 T minus 2, which is given in the fourth answer. Okay, that's a pretty easy one. So we will straight move into the question number 2. Question number 2. The power of a convex lens is expressed as 2 per centimeter. 2 per centimeter. The power is given like this. The usually divided power. So the power of the lens in SI units with sign convention is. So how the power is defined? Power is defined uh, so the power is defined by this equation. Power of a lens is equal 1 over f with a minus. And again, one important thing about this equation is when you're using, actually two important things. When you're using this equation, this f is the focal length of the lens. So you have to substitute the focal length in meters. Okay, first thing. Second thing, when you are substituting the focal length, you have to mention the sign convention. That is, for convex lens, focal length should be minus. Concave lens, it should be positive. Okay, the value should be substituted with the minus here, plus. So in this case, the power is given in per centimeter. So if you substitute here in meters, then only you get the proper value in the SI unit. So what we have to do is I have to convert this into per meter. That's when you get the SI unit. Okay. So how to convert into meters? Centimeter is in the denominator. So 1 centimeter is 10 to the power minus 2 meters. So this is the value. Actually, per meter we call it a diopter. Okay. So this is the value in SI units, but still you have to consider the sign convention. So what happened according to this equation? According to this one, if the lens is convex, then focal length is negative. If you substitute a negative focal length, then negative will be again positive. So power should be positive. So the final answer should be plus 200D. That's how you get the answer. So the third. Okay. Again, it's not that much hard. So the third. So if you have any questions, please raise 10 minutes. Okay. Third one, the option below has the same dimensions in both physical quantities. Okay. We are asking like which quantities have the same uh, dimensions. Yeah, if you see the answer, first angular momentum and torque. No, angular momentum and torque has the two different dimensions, so I don't need to uh, explain further. Surface tension and the spring constant. Yes. So surface tension, if you remember the definition, it's the force per unit length. That means the unit is Newton per meter. Again, the spring constants are the same unit. So because of same unit, they should have the same dimensions as well. So the correct answer is the second. Okay. Uh, Fourth question. Again, a pretty easy question. The frequency of a vibrating string can be doubled by. Okay. So frequency of a vibrating string. So when you meet the frequency, it means most of the time it is the fundamental. Or the fundamental frequency. So what is the formula for the fundamental frequency for a string? So if you remember, when you're talking about the standing waves, we derive that the fundamental frequency is given by 1 over 2L times root T over simple M. Here T is the tension, simple M is the mass per unit length of the string. Okay, so in this case it is not important. So how can we double the frequency? In these options, they have changed either the length or the tension. So they have keep this value constant. So if you want to like, so we will consider the proportions individual, like independently. So let's say for a case the tension is tension stays constant, tension එක constant නම් length එකත් එක්ක මෙහෙමනේ තියෙන්නේ variation එක. The variation with the length is like this. And if the length is constant, then the frequency varies with the tension like this. Okay. So if you want to make the frequency double, if you want to double the frequency, then you have to, so it is an indirect proportion, that means you have to reduce this length by a factor of 2. Okay. And if you want to double the frequency by changing the tension, so here you see this is a direct proportion, make a direct proportion there. Okay, if one side increases, the other side also increase. But there is a square root, there is a square root term. That means to make this double, you have to make the tension 4 times. You have to increase the tension 4 times. That then only the square root of 4 comes as 2, and the frequency will be double. Okay. So the answer should be first one, doubling the length, no, should be decreased. Doubling the tension, no, tension should be increased 4 times. Halving the tension, no, increases the tension by 4 times. So that answer is the fourth one. Again, pretty easy question. Okay, so the fifth one. Take notes if you want. Just take notes, and those who have done the paper, I think already have the marking. But still, ones who don't have, still copy it down, and marking will be sent to the main group again after this video. Otherwise, the people who didn't face the exam will not join the session. Okay, so the next one, AB is an isothermal, BC is a constant volume process, and AC is an adiabatic process. The graph which shows these 3 processes correctly. Okay, so isothermal, constant volume, adiabatic. Isothermal process means the temperature stays constant. These concepts come under the thermodynamics section of the thermal physics lesson. So maybe some theory students still haven't completed these theories. So don't worry, we will be covering it very soon. So next one, constant volume. So constant volume process, it in its name the thing is there. So the volume is constant. And adiabatic. Adiabatic means there is no any heat change. Okay. So if you sketch these processes in a PV curve, temperature constant means it should adhere the Boyle's law, PV constant. So PV constant curve is like this, something like this. Okay, and the constant volume process. Constant volume process means the volume is constant. So anything happen, the volume stays unchanged. So that kind of a process. So AB should be like this. AB is isothermal. So AB should be like this, and from B to C is a constant volume process. So what is the volume at this point? At B, the volume is this volume. So anything happen, the volume should be constant. That means the BC process should be either upward or downward along this line. We will see with the other process as well, and the adiabatic. So they have given this AC is an adiabatic process. Remember, for adiabatic processes, there is a relationship like this: pressure into uh, volume to the power gamma is a constant. So because of this gamma is some value which is nearly equal to 1.4. Or the make a 1.4 volt equal value wake up. So for this graph also, the shape of the graph is same as the PV equal constant or the isothermal graph. Isothermal එක වගේමයි. හැබැයි just remember the slope of this curve. Okay, the slope of this curve is much higher than, higher than this isothermal. Isothermal එකේදී මෙයාගේ වැඩි slope. So both these graphs have a negative slope, but for this curve the slope is higher. So it should go uh, below this isothermal process because as it starts from the same point. When the slope is high, when the magnitude of the slope is high, it should decrease drastically than the isothermal. So this is the variation. So BZ, this is isothermal. Just remember this as a factor. When you compare the isothermal and the adiabatic, slope of adiabatic or PV gamma equal constant graph is greater than slope of isothermal. Yeah, when I mean the slope, it is the negative slope. Negative slope. It's a factor. Just remember this. Sometimes this is useful. So what is the answer? The answer should be the second. Okay. So in the coming week, which is the first week of the February, or the second week, in the second week or the first week, we will have that one maths for physics session. There we will learn some tricks which can be used in solving MCQ type questions. Okay, that session will be very important for you. We can save a lot of time by using different techniques. Like when you're doing the paper in the exam, you can save a lot of time. We will look into that. Only thing again is the consistency. That's the main thing I expect from those who have joined this process. Okay. So if you have the consistency, we can do better. 100%. Okay, the sixth question. The intensity of 80 decibel siren is heard by him after passing 10 meters from the ambulance. What is the distance that he should pass the ambulance to hear half of the sound intensity level? Okay, so some person is passing an ambulance. So when he is 10 meters away, he hear 80 decibel. Yeah. So they are asking what should be the distance when he hear half of the intensity level. So intensity level is given by beta, not the intensity. So intensity level here should be 40 decibel. Okay. So just a comparison. So if like the same source, at the method sound emit කරන source එක එකමයි. So just a comparison. So how to do the comparison questions with sound intensity level? So we have learned the equation. If you haven't learned this, just note this. We can compare sound intensity levels using this equation. Okay, beta 1 minus beta 2 equal 10 log I1 over I2. Here you see this I is the sound intensity. Okay, sound intensity is given by this equation. Okay, for a stationary source එකක් තියෙනකොට යාගේ නම් r distance එකකින් sound intensity I නම් we say I is given by this equation. So here when doing the comparison, the sound is received from the same, like emitted from the same source. So P is a constant, that means I should depend on the distance. This is called the inverse square law. So we can just replace this I1 over I2 by using this. It should be R2 over R1 square. Again, we will learn these concepts, how these things come in that coming lesson. So now it's much easier. Beta 1 minus beta 3. Now I can apply the values. 80. So for the first instance, I am considering 80. For the second one, 40. Should be equal to 10 log. Here R2. R2 is the distance at beta 2. It is D. Divided by R1 is the distance at beta 1, that is 10. Again, there is a square. So this is 40. This 10 get cancelled. So D over 10 square is equal to 10 to the power 4. So you can take the square root of both sides. So it will be D over 10 is equal to 10 to the power 2. D is equal to 1000 meters, which is 1 kilometer. So the answer is the fifth one. So there's no need to go with the definition of sound intensity level, like that preliminary equation beta equal 10 log I over I naught. We don't need to use it here to compare. Sometimes in some students la department ඉගෙන basic equation එක දාලා හදනවානේ. This one. So I know it is the threshold intensity. We don't need to do that. Just learn this. You can compare. Okay. Really 7th question. Again, pretty easy one. Moving faster. So if you have any questions, please raise in the chat. A coconut falls from a tree and moves vertically downwards and takes 1 seconds to land on the ground. The vertical height from the ground to where the coconut was. Okay. So like this, there's a coconut. So it's detaching from the tree, the coconut tree. So you know when this detach from the tree, the initial velocity should be 0, and it takes 1.5 seconds to fall on the ground. So they're asking this height, vertical height. So simple motion equation can solve the problem. I don't know the final vertical velocity. So excluding the vertical velocity, I can apply the motion equation is equal ut plus half at squared. This is the motion under gravity. So h should be equal to the initial velocity 0. So 0 multiplied by time is again 0. Half into the acceleration is 10. Gravitational acceleration downwards. And the time taken is 1.5 squared. 1.5 squared is 2.25. When multiplied by 10 is 22.5 divided by 2, which is 11.2 meters. Okay. Simple one. 8th question. wave of frequency 100 hertz. Sorry, that's the main one. Eighth one, there are 50 parts of a vernier caliper which is attached to a mobile microscope. This is equal with 49 parts of 1 millimeter main scale parts. So what is the least count of the vernier caliper? So again, a pretty easy question. Least count is given by minus n over n or capital M. So here simple n means the number of main scale part. It's 49. Capital N is the number of total number of vernier parts. It's 50 into one part size is 1 millimeter. One main scale part is 1 millimeter. So when you solve this, it's a 1 over 50 millimeter. So first, then these vernier caliper questions. In these vernier caliper questions, so this is the formula in your figure guide. So when you're doing a figure problem, it's better if you apply this equation. Okay, it's better if you apply this equation in a practical question. But when doing these MCQs, you can take the least count easily. How? Just divide the main scale size by the total number of vernier parts. That is capital N. So that will give you the answer very straightforward. Which is 104. It method is also fine. Uh, Ninth question. Ninth one. A wave of frequency 100 hertz travel with a speed 10 meters per second along a stretched string. Consider the following statements when doing following statements. This is a stretched string. That's now where we see passing 10 meters per second. The frequency is given 1000 seconds. First statement, they say the wavelength of the wave is 10 centimeters. So we see we can determine the wavelength straightforward using V equal F lambda, the wave equation. So lambda should be V divided by F. V is 10, which is 100.1 meters. 10 centimeters. Yes, that's good. D is correct. Sorry, A is correct. Then B, the phase difference between 2 points on the string 2.5 centimeters apart is 5 over 4 radians. Okay, so how to do that? So we will consider a full wave cycle. අපි සම්පූර්ණ wave cycle එකක් ගමු. හරිද? So you all know හරිද ඔයාලා හැමෝම දන්නවා full wave cycle එකක් කියලා කියන්නේ phase එක ගත්තොත් 0 වලින් start කරලා 25 වෙනකන් වැඩි වෙනවා. 25 වෙනකන් වැඩි වෙනවා. So for full wave cycle the phase change is 25. And from full wave cycle, what is the distance, like the total length from here to here? It's the wavelength, right? This is the wavelength. We calculated it to be 10 centimeter. So again, this 25 value is given in radian. හරිද? දැන් මේ phase change එක අපි දින radian වලින් මේක degrees වලින් කිව්වොත් ඔයා 360 degrees if you remember. Okay, එහෙනම් 10 centimeters වලට තමයි 25. So half wave cycle, that's 5 centimeter. The phase change should be 180 degrees or radians වලින් නම් 5. So we are interested in the radian value here, but they are asking for the 2.5 centimeters apart. 2 points which are 2.5 centimeters apart, like this. So 2.5 means half of this value again. This is 2.5. So if the phase change from here to here is 5, if the phase change from here to here is 5, then here to here it should be 5 over 2 radians. So 5 over 4 is incorrect. Not 5 over 4. It's 5 over 2 only. So that's incorrect. This is correct. This is incorrect. C. If the tension of the string is 10 Newton, its mass per unit length is 0.1 kilogram per meter. So how to interrelate that? So if you remember, so here this wave is traveling along a string. So for transverse waves traveling along a string, we know the formula for the velocity is square root t over m. Here t is the tension, m is the mass per unit length of the string. So they have given the velocity. So I can subject in how I'm taking the square of both sides. Once I take the square, in a square root then I subject m. So I'm writing in a single step t over v square. See whether you understand it. So m should be, tension is given 10, velocity is again 10 square. So again 0.1 kilogram per meter. So the given value is right. Given value is right. So A and C are true. So the answer should be the fourth. Only A and C are true. Okay. Again, if you have anything to add to the marking or note it down, just compare with the marking, take it. Or otherwise, you can write it. Let me put the marking for the all difference. Easy. Marking is updated to the group, our WhatsApp group. Next one. So wires AB and AC of length 2R are soldered to circular wire of radius R so that the system lies in a same plane. Okay, so this arrangement is given. All wires have the same diameter and are made of the same material. So what happens when they have the same diameter and when they have made of the same material? වයකට diameter එක same නම් and with the same material, that means density is constant, then we can assume that mass per unit length sometimes we call lambda. The linear density of the wire is constant. So what happens when the linear density is constant? Linear density constant කියලා ගන්න පුළුවන් ඔය diameter එකයි මේ මෙතින rho වල value එකක් constant වුණාම මොකක්ද ඒකේ තියෙන يعني advantage එක. Advantage එක තමයි then the total mass of the wire එයාගේ total mass එක empty නම් අන්න ඒක එයාගේ length එකට proportional. ඒක length එකට proportional වෙනවා. මෙතන අපිට length එක බලලා length එකත් එක්ක masses compare කරන්න පුළුවන් වෙනවා. That's the meaning. So diagram is like this. The radius is R and there are two wires attached of length 2r. Okay, each the length is 2r. The center of gravity of the system is most likely to be located at. Right. Center of gravity කොහෙද තියෙන්නේ කියලා අහන්නේ. So how to simply solve this kind of problem? The first step is you have to mark all the masses included in the system at their relative center of gravity. So මොකද කරන්න ඕනේ මේකේ firstම we have to divide this the whole figure or the whole this arrangement to known shapes. හරි known shapes වලට divide කරගෙන අපි දන්න COGs වල හරි center of gravities වල දන්න masses ටික mark කරගන්න ඕනේ. So I'm going to do that. Here I'm going to like deattach these two wires. So one wire, and this ring. So for the ring, the mass should be there. I mean, the center of the mass of this ring should act at this center. Ringing mass is center. And what is the mass? How to compare? You see, if I take the mass of the ring as mr, mr කියලා ගත්තාම මේක ඔයාලට තේරෙන්න ඕනේ මේ proportional වෙනවා මෙයාගේ length එකට. That means length එක අපි දන්නවා 2πr නේ. Circumference එක 2πr. අතර 2πr කියන value එකට proportional. ඊටම මෙයාගේ mass එක නම් මෙතන mark කරගන්නවා 2πr lambda කියලා. Lambda is just a constant. හරිද? අර නිකන් මේ තියෙන length එක convert කරන constant එක කියලා දාන්නකො. හරිද? wire lambda. And for this thread or the wire, again, what is the length? They have given the wire, the length is 2r. So again, this mass of this wire should be proportional to its length. Length is proportional, right? So it should be proportional to r. So I'm marking it as 2r lambda. So initially I said, if this density and the diameter is constant, this mass per unit length is constant. හරිද? ඒ වුණාම අර මේ multiply වෙන constant එක දෙකෙම එකයි. ඒක තමයි එතන තියෙන වාසිය. So here again it should be 2r lambda. So now I consider a couple of these like simultaneously. So the මේ දෙන්න ගත්තාම මේ masses දෙකේ center of gravity තියෙනවනේ මේ දෙන්න මැදනේ. හරිද? equal masses දෙකක්. So the center of gravity should be here. So මට මේක replace කරන්න පුළුවන්. මේ තියෙන දෙන්න replace කරන්න පුළුවන්. මේ දෙන වෙනුවට මෙන්න මෙතන 4r lambda එකක් තියෙනවා කියලා. I think you all can understand it. Then I have to consider this one and this one. So what should be, I mean, what is the highest one? Which one has the highest value? 5 is nearly equal to 3. So 3 times 2 is 6. එහෙනම් මේ නිකන් value එක බලුවොත් මේක 6r වගේ තියෙනවා. Here it is 4r. You all know masses දෙකක් තියෙනවා නම් මේ දෙන center of gravity එක වැඩියෙන්ම එක පැත්තකට displacement එක displace වෙන්නේ mass එක වැඩි කෙනා පැත්තට. Center of gravity is always displaced in the direction of the higher mass. So this if the ratio is a to b, then a over b is equal to m over m as well. Okay, these concepts we can like revise in the tomorrow session. So here the center of gravity should be like, if this is the midpoint, it should be somewhere closer to this 2πr lambda because this is the higher mass. So what is the correct? And also the ratio of the length you have to consider. If you consider the ratio here a to b, then a to b should be 2πr to 4r. That is like 3 to 2. So the most appropriate answer is the location is r. R is the location which is given in the third. Again, not that hard. Just if you did not know this concept, make if the wire is made of the same material and the diameter is the same, then the mass per unit length is constant. හරිද? අපි value එකක් කතා කරන්නේ wires වලදී මෙහෙම එකක්. per meter කොච්චර කිලෝග්‍රෑම් ගණක් තියෙනවද? 2 කිලෝග්‍රෑම් per meter කිව්වොත් wire එක මීටර එකකට එයාගේ බර 2 කිලෝග්‍රෑම්. අන්න ඒ value එක constant. හරිද? ඒ value එක constant වුණාම අපිට total mass එක ලියන්න පුළුවන් මොකක් හරි constant එකක් times its length කියලා. That means simply mass is proportional to the length. This case is valid for the areas as well. Okay, sometimes they give the questions with areas. So again, if they have mentioned the thickness and the density is constant, this thickness of this plate, the thickness and the density is constant, again we can do the same thing here also, but the total mass is now proportional to not to the length, but here it is the area. So in that case, we can again make this equal with another constant. We normally use sigma. Okay. The volume you all know. For the volume, the total mass is proportional to, is equal to volume times density. Here is the density. That's additional. Okay, we're done with that. The one question. Again, we can find many of this this similar type of questions in your like the previous past papers within past 10 years. So this diagram is not to the scale. Okay, what does it say? 3/4 of the length of a metal rod is covered well. Covered well means it is lagged, fully lagged. Those who have studied this part will know what does it mean by them. They say it is lagged. And 1/4 is kept exposed to air. Is not. Which of the following graphs correctly represent the temperature? Shows the temperature change theta contours කියලා දෙලා තියෙනවා. It should be corrected again at the steady state. Contours thing should be mentioned, like what they have mentioned is at the steady state. Okay, so again, not a big deal. Remember, when rod is perfectly lagged, rod they are perfectly lagged කරලා තියෙනවා. That means there cannot be any heat flow in the transverse direction. Transverse direction එකේ heat flow එකක් තියෙන විදියක් නැහැ. Okay. So the heat can only flow in the longitudinal direction. So like this. Normally dq by dt. Use this convention. Heat flow only occurs in the axial direction or the longitudinal direction. But here it is with air. So when there is air, there can be transverse heat flows as well. Some heat will flow axially, but not all. There will be some flows in through the surface. Remember, if this happens, if the metal rod is lagged, then when the axial heat flow occurs, the temperature gradient stay constant. Okay, its temperature gradient is constant. What is mean by temperature gradient? Temperature gradient is the gradient of this graph. හරිද? theta versus x එකේ gradient එක තමයි delta theta over L කියලා කියන්නේ. හරිද? This is mainly given by this law of conduction. dq by dt is equal to ka delta theta over L. Those who have done this will know this. If the conductance, conductivity is constant, then the area is constant. Then if this dq by dt is again constant, then this should stay constant as well. මේ අනිත් හැම එකම constant කියන්නේ මෙයත් constant වෙන්න එපා. So if this has a, like, this is the gradient. So if this is a constant value, then this should be a straight line. For this region, gradient is constant, so it should be a straight line. And remember, to the direction of heat flow, the temperature always decreases. Temperature හැම වෙලේම අඩු වෙනවා. And then for the rest, what should happen is, again you can apply the conductivity law, law of conduction. Here again, for the same rod, this k and section is constant, but you can see if the heat is lost in the transverse direction, heat එක එක දිගට යද්දී මේ transverse direction එකෙන් loss වෙනවා නම්, එහෙම loss වෙනවා නම්, then the rate of axial heat flow continuously decreases නේ. කියන්නේ මේ හරියේදී axially ගියපු heat flow එක නෙමෙයි මේ හරියේදී යන්නේ. මොකද මේ මැද ටිකක් loss වෙන හින්දා මෙතනදී ආපු heat එකට වඩා උඩු ප්‍රමාණයක් තමයි මේ කියන්නේ. I think you all can understand. So when the heat flow losses, the gradient should decrease. When the rate of heat flow is decreased, the temperature gradient also should decrease. So decreasing the gradient should look like this. So the correct answer should be the fourth. If you have questions, please raise in the chat. So 12th question. Lift with mass 1000 kilogram goes down with 5 meters per second uniform speed. Comes to rest after 10 meter per square second of uniform deceleration. I think it should be 10 meters per second. It mentioned the displacement. Okay. So if friction is negligible, what is the tension attached to the cable when it decelerates? So there is the elevator, and these are the acceleration and the deceleration. The movement of this elevator is done using a cable. This is the cable. So the mass is 1000 kilogram. What happens is it initially moving down with meters per second velocity. In these rates, and stops within 10 meters. Within the 10 meters, its velocity becomes 0. They are asking what is the tension. Okay, so when we consider the forces, when the forces are considered, the weight is there and the tension is there. So I can calculate the tension how? Using what? Using Newton's law. But still, to use Newton's law, you have to know the acceleration or the deceleration. So first calculate the deceleration. How? Here the time is not mentioned, so I am excluding time using a motion equation. So downwards, v squared equal u squared plus 2as. Final velocity is 0. Initially it is 5 square, and it is deceleration. That means the acceleration is in this direction. So it should be minus 2 times a times displacement is 10. So acceleration comes as 25 divided by 20, which is 1.25 meters per square second. Okay, so now I have to apply it this formula, Newton's law words. So F equal ma, the upward direction should be t minus 1000. Even if it moves downwards, we can apply Newton's law upwards. ඒක අපේ choice එක. හරිද? Okay, downwards move වෙද්දී downwards මේ F equal ma දාන්න ඕනේ කියලා එහෙම මුකුත් නැහැ. You can apply either way. So t minus 10,000 is equal to the mass is 1000 times the acceleration. So you see, this acceleration is also acting upwards because it is decelerating downwards. Decelerating downwards means acceleration upwards. So upwards is positive. The value 1.25. So what's the value? 1.25 means 1250 plus this 10,000, 11,250 Newton, which is given in the fourth. Okay. Thirteenth question. The figure shows a mass simple M hanging from three light identical springs. When the mass M is pulled downwards slightly and released, it engages in simple harmonic motion. We all know that. If the spring constant is K, then the corresponding period will be. Okay, that spring constant K is for one spring. Here system spring constant K. So the system is like this. There's one spring. This can be two. So the time period is given by 2 phi square root M over K. Time period is given by this equation. So when you're applying values, M is the mass which is hung using the springs, and here K is the equivalent spring constant. We have to calculate the spring or equivalent spring constant. How? Remember, for springs, if two springs are in series connection, this is what we call series connection. When the springs are end-to-end connected, we call it series connection. Then the resultant or the equivalent spring constant is given by this equation. 1 over k is equal to 1 over k1 plus 1 over k2. And if the springs are in parallel, like this, then the equivalent constant is given by the sum of the constants. So here, these connections have both. These two are in parallel, and the equivalent of this system with this is series. These two are parallel, and equivalent of this with this is series. So first I'm going to evaluate for these two. Parallel connection, that means just the sum. That means the equivalent of these two is 2k here. This is a parallel connection. Ends are connected each other. Both ends are connected. So this one and this one is again, they are in series. So how? Now if I solve these two, 1 over k naught should be equal to 1 over 2k plus 1 over k. So k naught should be equal to, so take the common denominator. So I have to multiply this one by 2. Common denominator ගන්න මෙන්න මේක දෙකෙන් multiply කරන හරි. So once I do that, this will be 2. 2 plus 1 should be 3. It means 2k over 3. This is the value. So when I apply this to this equation, I get the final value 3m over 2k. Again, I think you all can understand. If you don't remember these theories, please make notes of them. So in the marking, they haven't been mentioned. So these things are, so you can revise on those theories which are frequently used in MCQ questions. Even in structured essays also, these formulas will be very useful. This equivalent spring constant concept, because there is a practical as well in this section. Okay, the 14th. 14th. What is the minimum time taken to boil 2 kilograms of water from 20 Celsius to boiling point using 1 kilowatt immersion heater? The specific heat capacity of water is 4200 joule per kilogram per Kelvin. Okay. Minimum time to boil this water. Okay, so the boiling, for the boiling process, the heat change, for the boiling process, the heat change I can calculate using delta Q equal mc delta theta. Okay, so I can calculate the required heat. So what is the required heat? The required heat is I'm boiling 2 kilograms of water, and the specific heat constant is 4200, and the temperature difference, initially the water is at 20 Celsius. What is the boiling point? So you have to know boiling point of water is at 100 Celsius. So the difference is 100 minus 20, the temperature difference. So what's the value? It is 80. Okay, we will keep the value here. We will just keep the values. It should be 84 times 8 10 to the power 1, 2, 3. They're asking the time. So how to calculate the time? The power is given. Power is rate of spending energy. So I can calculate the time dividing the total energy by the power. Simple. So the total energy required is that heat energy we calculated earlier. So this is the value. And the power is 1.5 in the power 3. These 10 to the power 3s are getting cancelled. So if you solve this, okay. So if you solve this, the value should come is 448 seconds. But the answers are given in minutes. So divide it by 60 to obtain the value in minutes. So if you divide it, divide by 6, yeah, should be 7, and 28 is 4 and 7.46 minutes. That is nearly 7.5 minutes, which is given in the second answer. Okay. Fifteen. It is again a very easy question, but you can complicate it. 15th one. The following diagram indicates two equivalent triangular prisms placed together. Two equivalent triangular prisms. A monochromatic ray is incident on AB side. The angle is given theta. Monochromatic light ray කියන්නේ frequency එකයි තියෙන්නේ. මේ light ray එකේ තියෙන light wave photons වලට එක frequency එකයි තියෙන්නේ. ඒක වදින්න theta වලින්. When this light ray emerged to air, මේ මදිනක මෙහෙ ඉදිරියට නැත්තේ. Find the angle between normal and the emergent ray. So let's say it is going to image here. Think emergent angle. They're asking what should this angle be? Is alpha. So what should it be? So in the diagram they have marked that both these prisms are made of the same material. That means the refractive indexes are same. So if the refractive indexes are same, indices are same, will there be any deviation when traveling through this interface? මේ interface කරා එනකොට මොකක් හරි අවුලක් තියනවද? නෑනේ. Same material නේ. So there is no any refraction occur here. මෙතනදී refraction නැහැ. So if there is no any refraction, like there is no point of considering this line. නේද? ඔය line එක consider කරලා වැඩක් නැහැනේ. So if you don't consider this line, you can consider this whole thing, this whole setup as a medium with parallel side. Medium with parallel sides. Okay. If this is a medium with parallel sides, what should happen? The angle of incidence and the angle of emergence should be equal, isn't it? This is a basic theory we learn in this section of physics. The optics වල මේක අපි ඉගෙන ගන්නවා. So if the medium has if the medium has parallel sides, then the angle of incidence as well as the angle of emergence should be equal. Okay. So the answer should be the second option. Yep. The marking there is another way. So if you get it, only read through it. I'm not going to explain it here. That's kind of I think I find it kind of complicated for students. So this is very easy. This way is very, very easy. Okay. 16th question. What is the extreme speed of an air bubble if an air bubble is moving upward in a lake with extreme speed of x naught break in 3 ideal bubbles? So here extreme speed is nothing but the terminal velocity. Okay, extreme speed කියලා උතන කියන්නේ terminal velocity. So there is a lake. So inside the lake, one air bubble is moving at a speed of the terminal speed x naught. So this is the terminal speed for this air bubble. So then what happens is this is going to divide it into 3 equal bubbles. So what should happen? So if this is going to divide into 3 equal bubbles, still the total air volume should be the same. The air volume which was here should be equally divided into these 3 air bubbles. So if I consider the radius, like so if you remember, this terminal velocity is dependent on the radius. So if you consider the radius in this case as capital R, in this case if you consider simple R, you can build up a relationship between these two radius by considering the volumes. How? 4.35 R cube, the total volume of the sphere, should be the same volume of air in these 3 small bubbles. So 3 into 4.35 R cube, these things get cancelled. So if you take the cubic root, so what do you do by taking the cubic root? අද cubic root එක ගන්නවා කියලා කරන්නේ sides දෙකේම 1/3 power එක ගන්න එක. හරිද? So when you take the 1/3 power here, this 3 will be cancelled. But here, for this 3, there is no any power. So 1/3 power is there. And for R, again, the powers cancel. So I get a relationship. The small radius is equal to R divided by 3 to the power 1/3. Okay. Now, it's a comparison. So we will learn these comparison type questions in the coming physics lesson. Actually, taking it that way is much easier. So what's the equation for the extreme speed or the terminal velocity? Terminal velocity is given by 2 upon min a square over eta rho upon rho minus sigma times t. Here you understand for both these cases I'm going to compare. So when I compare these two, this is air, again this is air, so the same material. Again the lake, the density is also same, so this density difference should be same in both cases. G is always the same thing, and if the same liquid, this neta is also not going to change. This thing also is a constant. That means the terminal speed should depend on the radius square only. So now I can compare. So let's say the extreme speed or the terminal velocity in this case is x. X. So if I get the relationship like the proportionality like this, then I can divide x over x naught. And comparing these two, x over x naught should be equal to ratio of the radii to the powers 2. Here, the square of make a square. So I should have, now I can calculate the extreme speed x in terms of x naught. Just cross multiply. X is equal to x naught times simple R over capital R. Here you got something for that ratio. See, simple R is equal to capital R over this thing. So simple R over capital R, you can calculate from the same thing, is 3 to the power minus 1/3. See, you get it. මේක මේ පැත්තට ගෙනාව නම් 1 මේකේ එක යට මෙන්න මේක තියෙනවනේ. එක යට තියෙන එක මට උඩ ගන්න පුළුවන් නෙගටිව් පවර් එකක් විදිහට. Like here. So there is the minus. So square. So if you remember the laws of powers, power of a power is nothing but the multiplication. Power එක power එක කියන්නේ multiplication. එතකොට මේ -1/3 කියන්නේ 2 වලින් multiply කරන්න තියෙන්නේ. So it will leave you this value 3 to the power minus 2/3 x naught. So this is the new extreme speed. So which is given in the fifth answer. It's a good question. 17th. If the length and the mass of a ladder AB is 4 meter and 2 kilogram respectively, the minimum amount of work to be done to lean the ladder on a wall with 60 degrees inclination to the horizontal as shown in the figure is. Okay. They're asking what is the minimum work required to lean the ladder. දීලා තියෙන විදිහට wall එක දිගේ lean කරන්න කොච්චර එන්ජයක් කොහොමද කියලා අහන්නේ. හරිද? So what is the minimum work? If you solve these kind of problems, even in gravitational field is as well. So what is the minimum work? When you say minimum work, if you are changing the position inside the gravitational field, what is the minimum work? If you are changing the position in a gravitational field, the minimum work is the increase in the potential energy. This is the minimum work or the minimum amount of energy that you should supply to do this. Minimum work increase in potential energy. So how this potential energy increase here? Understand, initially this rod initially this ladder it is horizontal on the floor. Now I'm gonna lean it on this wall at 60 degrees. So here in the first case the center of gravity is somewhere here in the middle, so the position is here, and in this case the center of gravity has been displaced upwards, you see. So finally the center of gravity is somewhere here. So if the total length is 4, then this half should be 2 and 2. So the displacement of the center of gravity is 2 sine 60. You see, the displacement of the center of gravity is 2 sine 60. Remember, the increase of potential energy, you always have to calculate this increase in potential energy considering the displacement of the center of gravity only. Okay? Nowhere else. Center of gravity එකේ වෙන displacement එකේ වෙනස තමයි හොයන්න ඕනේ. This is the initial position. Here is the final position. So you can calculate the difference. How? mg delta h changing the displacement. So the mass is 20, g is 10, displaced length is 2 sine 60, 40, 400 into root over 2, which is 200 root 3 joules even in the third. Okay, this is also fine. Again, I am reminding, tomorrow there will be the second session of that online recap series. Like we have to cover the energy concepts, equilibrium, and the center of gravity concepts using the MCQs. So it will be done. But there is a point like this. So these paper classes I'm going to continue because there's physical students. So for the physical students, I'm going to continue this. So if someone is online, you can still join this. But this online recap series, so if this student count is low, I think no point of doing that. That means the students do not need it. Well, I didn't get much comments at all. So if you students do not need it, like In meantime, I also get first one කරගෙන යන්නේ මොකද කියලා මට හිතෙනවානේ. Even the physical friends also do not join. So I don't know whether if they still physical class queue කට්ටියට. So today also I do not see much attendance in both the YouTube and the Zoom. So if that's gonna continue, let's see. Okay, so 17th, sorry, 18th. A is a circular shaped plate with a cavity. Okay, the radius of B plate is equal to the interior radius of A. When exert equal and separate torque, they get alpha A and alpha B angular acceleration. If C is an object formed by combining A and B, what is the angular acceleration of C? A is there, kind of a ring. Then there is the plate B, and there is the combined one. Okay, so in each case, the same torque is applied. They have mentioned it here. In all three cases, the tension is, torque is the same. So here torque, here the same, here also the same torque. So under the same torque, here the angular acceleration they have given alpha A, here it is alpha B, and they're asking what is alpha here. So how to relate alpha and torque? Torque and alpha relate common. That's the Newton law for circular motion, isn't it? Tau equal I alpha. In circular motion, tau is the external disturbance or the external influencer. Torque. So when it is influenced, there will be an angular acceleration. Tau equal I alpha. I is the moment of inertia. So let's take the moment of inertia of A is IA, here IB, and IC. I don't need to take separate IC because this is made of combination of these two. That means IC or the moment of inertia in this case should be equal to the sum of inertias in the previous cases. Okay, so we will write expressions for the given data. So when I write the expression for this one, so should be equal to IA alpha A. So we will see how to use these. For the second one, I can write the same thing, IB alpha B. Second. Now I have to write the equation for C. So C, total inertia is, moment of inertia is IA plus IB times alpha. So need to determine alpha. Alpha should be tau divided by IA plus IB. Okay. So you see, to calculate this alpha, you have to get rid of these tau values. I mean, tau, the symbol and these I symbols. Are the I tau symbols they are make කරන්න බෑනේ. The only the given symbols are this alpha A, alpha B. These are the only given values. So how to get rid of these things? So I'm gonna do something like this. Here you see there is a IA, here it is a IB, and I can take formulas for IA and IB independently using these two. So from the first one, IA should be equal to 2 over alpha A. This is something I do just by seeing what I need. මේක හදන්නේ මොකක්ද කරන්න ඕනේ කියන එක බලලා කරන වැඩක්. හරිද? First one. Again IB 2 over alpha B. So let's say I'm gonna replace I values. What will happen? 2 divided by IA is 2 over alpha A. This is 2 over alpha B. So ඔයාලත් ඒ වගේ වැඩ කරන්න. කොහොමද කරන්නේ? කරන්නේ ඉතින් ඒක තමයි practice එක. හරිද? That's why you need the practice as well as the trained eye වගේ I එකයි not the eye, it's a brain. You need a trained mind. ඒවා කලින් දැකලා තියෙන්න ඕනේ. එතකොට ඔයාලට ටක් ගාලා කරන්න පුළුවන්. හරිද? එතන එන්න මොකද්ද වෙන්නේ? 2 divided by, you see here I can take a toe out and this toe will be cancelled. This toe getting cancelled with the one in the numerator. So here this can be solved very easily. Take the denominator. So once you take the common denominator will go up like this, alpha a alpha b divided by what is in the numerator here. So numerator will be alpha a plus alpha b. So the answer is given in the fifth option. Width of a human eye is 2.5 centimeter. Figure दिया था. Looking at his near point, the focal length of the eye lens is 2.3 centimeter. Okay. So when it is observing his near point, let's say this near point is here. So when he is observing here, the focal length of this lens is given 2.3 centimeter. So the least distance of distinction is, human eye. This is a very marvelous creation. So this lens can adjust its focal length by using these ciliary muscles to see objects placed at different distances. Okay. lens එකට පුළුවන් යාගේ අර focal length එක වෙනස් කරගෙන different places වල තියෙන objects බලන්න. So in this case it is focused to see the near point නේ. So seeing the near point is if you place something here, the image should be made on the retina here. So distance is given, image distance is given. So they are asking the least distance, that is the object distance here, isn't it? eye lens එකට සාපේක්ෂව මෙයානේ object distance එක. මෙතන තිබ්බොත් මෙතන පේන විදිහට මේ තියෙන්නේ. So just apply lens formula considering this case. So the final image is after the lens 2.5 centimeters. So if it is after the lens, then minus 2.5 minus the object distance, that is the value d, least distance කියලා කියන්නේ ඒකනේ, should be equal to the focal length minus 1 over 2.3. So negative terms can be cancelled. Negative එකක් මෙහෙන් එකට අරගෙන අනිත් කපලා දාන්න පුළුවන්. So 1 over t is equal to like this. Take a common denominator. D is equal to 2.3 into 2.5 divided by 0.2. Okay. So what do you get if you solve this? We end on a So if you solve this, you should get this answer. 28.75 centimeters. That is given in the third one. 20th telescope has a magnifying power of 20 when it is in normal adjustment. Its net length is 25 centimeter. If its eyepiece is taken as a simple microscope when it is in normal adjustment and its near point is 25 centimeter, what is the angular magnification of මෙහෙම lenses දෙකක් තියලා telescope එකක් හදලා තියෙනවා simple telescope එකක්. normal adjustment එකේ තියෙද්දි magnifying power එක දීලා තියෙනවා. So in the normal adjustment the magnifying power you can calculate simply by the ratio of the focal length. Focal length of object divided by the focal length of eyepiece. So you get one relationship between these two values. Values දීලා නැහැනේ. And they have mentioned the total length as well. So what is the total length? 52.5. So if the telescope is in normal adjustment, means the final image is also formed at the infinity. That's theory. Theory එකේ කියන්නේ normal adjustment එකේ නම් තියෙන්නේ final image එක හැදෙන්නේ infinity වල telescopes වලදී. Okay? Telescope වලදී infinity. So if that's the case, you understand the ray diagram should be something like this. So if the ray diagram is something like this, then the length, the total length of the tube should be equal to the sum of the focal lengths. Can we length එක focal length දෙකට සමාන වෙන්න බෑ මොකද parallax තමයි එන්නේ. හරිද? infinity වල තියෙනවා බලනවා නම් parallax එනවා. ඒක converge වෙනවා. That means මෙන්න මේ length එක මේ focal එකේ මෙතන ඉස්සරහා තියෙන lens එකේ focal length එක වෙන්න ඕනේ. object එකේ focal length එක. ඊට පස්සේ ඉතින් එළියට යන්නේ parallel lights නම් ඒ කියන්නේ මේ lens එකට සාපේක්ෂව මේ distance එක එයාගේ focal length එක වෙන්න බෑ. නැත්නම් parallax එළියට යන්නේ නැහැ නේ. So FO plus FE should be 52.5. So I can solve this simultaneously. So FO is 20 FE. 20 plus 1 FE is 52.5. FE is equal to 52.5 divided by 21. When you divide this, you should get something like 2.5. Yeah, 2.5 centimeter. හරි. එහෙනම් මේ data දෙකෙන් අපිට මේ focal length එක හදා ගන්න පුළුවන්. But they are not asking that. They are asking now they're gonna use this eyepiece as a simple microscope. Normal adjustment එකේ තියෙන simple microscope එකක් විදිහට ගන්නවලු eyepiece lens එක. Okay, so the nearest point is given. What is the magnification power? They're asking the magnification power. So if you remember the formulas, you can directly apply. For a microscope in normal adjustment, the magnification is given by d over f plus 1. Lens එකේ focal length එක යට තියෙන්නේ d කියන්නේ අර nearest point එකට තියෙන distance එක කියන්නේ 25 කියන එක. ඒතර ඕකට දාන්න තියෙන්නේ හරිද? මේක 25 මේක 2.5 එක හොයාගත්තා fe plus 1 which is 11. Or else you have to come from the definitions හරිද? ඒක මම කියන්නේ මේ ඔය optical instruments වල formulas වගේ අපි derive කරනවානේ. ඒක පොඩ්ඩක් ඔළුවේ තියාගන්න. But remember these formulas you can't apply in essay questions. මේවා essay questions වල direct දාන්න බෑ. Then you have to prove this. But still for the MCQ these are very useful. Otherwise you have to start from the basic principles and derive the equation and substitute the values. That's kind of a time consuming process. I don't say hard, it's not hard, but time consuming. So the answer should be the fourth one. Okay, that's a good one. Okay, 21st. 21st. Figure shows the capillary tube immersed vertically in a beaker of soap solution. Soap solution is the soap bubble is formed at the top of the tube. Hari, the correct graph which shows the variation of pressure P along ABCDE is. Right. Tube එකක් තියෙනවා මේ tube එක capillary tube එක මේ soap solution එකේ ගිල්ලලා ඒකේ උඩ මේ soap bubble එකකුත් හදලා තියෙනවා. So they are asking the pressure variation. In this case the pressure variation along this ABCDE. So guys E is here. Is the level of free surface. Free surface එකේ level එකේ තියෙනවා. Okay, so they are asking the pressure variation. So you know when there are bubbles inside, outside, be pressure difference. And again, when there is a meniscus, again, just above and just below difference, which is given by delta P equal 2T over R. Here, in the previous case, the pressure difference inside outside is given by delta P equal 4T over R, twice as the previous one. And again, the pressure is vary from D to E because of this liquid height, you know, the static pressure liquid height එක depend on it. So that's that thing is also there. And finally, final thing is this outside the atmosphere there will be a constant pressure which is the atmospheric pressure. හරිද? සාමාන්‍යයෙන් P note වලින් තමයි indicate කරන්නේ. So we will see how the variation is. I'm gonna get the graph and mark the points A, B, C, D, E. So starting from A, B, C, E. Okay, you see, from A to, I'm considering the pressure along this line. Consider the pressure along this line. So consider I'm traveling from here to downwards. Initially, I should feel the atmospheric pressure. I'm exposed to the atmosphere. That means the pressure should be the atmospheric pressure. So at A, the pressure should be the atmospheric pressure. Starting somewhere here. Okay. Let's say this is the atmospheric pressure. So to some extent, this is the atmospheric pressure. Then you're going to travel across this boundary. Better than so bubble like a. So you remember there is a pressure difference 40 over R, and where the pressure is high, inside outside. When you consider the inside and outside, you know the pressure inside is high. Outside pressure එකට වඩා මෙන්න මෙච්චර ප්‍රමාණයකින් inside pressure එක වැඩි. හරිද? So that means there should be a pressure difference. Like when you just enter from this point, the pressure should increase. එක part එකම depend on. So this pressure difference is given by what? 40 over R. Okay. And then once you enter from this boundary, මෙතන boundary එකෙන් ආපු ගමන්, then again this is a air region නේ. මේක ඇතුළේ තියෙන air region එක. So what should happen is inside a air region the pressure remains constant. So when you fill some vessel with some air, the pressure at each and every point will be the same. Gas was the කතා කරනවා. නවතන pressure එක සමානයි. So from this point to until point C, okay, from this boundary until to this point C, the pressure should be constant. Okay, so I'm just sketching C here. So until C, the pressure is constant like this. AR region. Then how to do? The method is like this. You see, this free surface එක තියෙනවනේ. So at the free surface, what should be the pressure? So at the free surface, the pressure should be the atmospheric pressure. කියන්නේ E කියන point එකේදී ආයෙත් කොහෙම හරි මේ graph එක හැදිලා එන්න ඕනේ pressure කරන්නේ. Along D to E, what should happen? D වලින් ඉඳන් ඊට එද්දි මොකද්ද වෙන්නේ? There is the liquid column. So for a liquid column, you should understand this PD plus some H rho G is equal to PE. මේ liquid column එක ගත්තාම ඕමනේ equation එක තියෙන්නේ. ඒක මොකද්ද? අනිවාර්යෙන් PE should be greater. TD ට තව කාලයක් එකතු වෙලා hydrostatic pressure එක එකතු වෙලා තමයි PE එන්නේ. Still PE should be P naught. PE කියන්නේ atmospheric pressure එක වෙන්න ඕනේ. හැබැයි PE කියන කෙනා D ට වඩා වැඩි. කියන්නේ D වල pressure එක මෙන්න මේ value එකට අතර අඩු වෙන්න ඕනේ. කියන්නේ atmospheric pressure එකට අතර අඩු වෙන්න ඕනේ. But the variation should be linear. You see, with the distance, this relationship is linear නේ. නිකන් graph එකක් කරනකොට y equal mx වගේ නෙන්නේ. So starting from a lower value, it should increase like this from D to E. Okay, now from C to D, again C is somewhere here. D somewhere here. So මේ CD දෙන්න අතර මැද්දේදී වගේ තමයි ඔය මේ meniscus එක තියෙන්නේ. So if this is C and this is D, the meniscus is somewhere here. So until that point, this pressure is constant, and that meniscus මේ meniscus එක ගාවදී මොකද වෙන්න ඕනේ? මේක එකපාරටම මේ D වල තියෙන value එකට drop වෙන්න ඕනේ. හරිද? කියන්නේ මෙහෙම එකපාරටම drop වෙන්න ඕනේ. ඒකට අර මේ මෙන්න මෙතන values වල compare කරන්න මම එකක් කිව්වා මේ formula එකෙන් බලන්න කියලා. That thing only you can only do that thing when the radiuses are mentioned. හරිද? radius සමහර තරම් වල දෙනවා. දැන් මෙතන දීලා නැති හින්දා අපිට ඒක කරන්න බෑ. ඒකට එහෙම වුණොත් තරක් ගන්න formulas වලින් compare කරන්න බෑ. ඒකට consider කරන්න වෙන්නේ අර ඉවර වෙන point එකේ pressure එක කොහොමද තියෙන්නේ සහ මේක ගන්න වෙලාවෙ නම් කොහොමද variation එක වෙන්නේ. ඒ ටික consider කරාම ඔයාලට final answer එක යන්න. Okay. That's why Okay, I think it's clear. And also, if you require further clarification, you can see the marking as well. The marking also, I think it's clearly like how given discussion for the question. Okay, I think that will be for this 21st one. And next is 22nd. Okay, 22nd, graph showing the variation of kinetic energy E with displacement x of an object which is moving from rest on a smooth horizontal surface is the surface with constant acceleration is. So an object is moving along a horizontal surface with a constant acceleration. So they are asking which option correctly show the variation of kinetic energy versus the displacement. So when you get this kind of question, always try to like build a relationship between the dependent variable and the independent variable. So we will try to do that. How? Uh, First, you can interrelate this displacement with velocity. හරිද? අපිට kinetic energy දෙක ගන්න බෑනේ. You can calculate the kinetic energy when you have the velocity. So I'm gonna find the velocity. How? Just use a motion equation. For the final velocity, v squared should be equal to the initial one is 0 plus 2 times a times x. 2ax. So what's kinetic energy? Kinetic energy is half v squared. Half m 2ax. So you get something like this. See, so when you get energy into y-axis and this displacement into x-axis, the variation should be y equal mx. That is something like this. Straight line with a positive gradient to origin. First answer. Point 3. There are three liquids with three different densities, rho 1, rho 2, and rho 3, in a U-shaped vessel. Out of the following, which one shows the correct relationship among these liquids with different densities? Okay, so the correct relationship between these. Another easy question. Usually, like, you don't find these kind of easy questions in the last few questions in a paper. Okay. So if you know the correct relationship, you can take the value very easily. How? So consider the interface. Okay, so I'm going to consider the static pressure, this xx dash horizontal line. The xx dash in a horizontal line again. මේ rho 1 කියන liquid එකයි rho 2 කියන liquid එකයි අතර තියෙන interface එකේ තියෙන horizontal level එකේ pressures consider කරන්න හදන්නේ. So what's the pressure at this point? You all know here this is a continuous liquid. From here to here, this is a continuous liquid. So for a continuous liquid, the pressure at the same level should be equal. So the pressure at this point should be the pressure at this point. Okay. So pressure at this point, I'll consider it as A, the other side as B. So the pressure at A is equal to the atmospheric pressure plus the pressure by this liquid column. That is H1, or I'll rather write the values, 15 rho 1 G is equal pressure at B. So pressure at B is the summation of the atmospheric pressure plus the pressures by these two liquid columns. So from the rho 3 one, the pressure is 10 into rho 3 G, and from this rho 2 density liquid, red color liquid again, here this side should be, then here you see this total height is the same thing. The total height of the liquid is the same thing. So this value is 15. So this again should be 15. This is, and then this should be 5 into rho 2 G. P not get cancelled. G get cancelled. So once you divide whole expression by 5, 3 rho 1 is equal to 2 rho 3 plus, just be first. Fourth one. Consider the following statements involving the standing wave. Let's do these last two questions also very quick, and then we will take a small break, and we will discuss the structured question as well as one essay. Okay, we will try to cover most of the paper in these 3 hours. Okay, so statement A. So all these statements are about a standing wave. First one, frequency of each vibrating particle is the same. So let's say this is a standing wave, human standing wave, and so make up මෙහෙම standing wave අන්දට standing wave එකේ හැම වෙලෙම particles තියෙන්නේ මේ lines වල හැම වෙලෙම නෙමෙයි තියෙන්නේ. What we draw is just kind of like a boundary. මේ තියෙන්නේ මේ particles vibrator boundary එකක් විතරයි. So let's say I'm considering the particle at this point. මෙතන තියෙන particle එක, what happens is this will vibrate in this space. මෙන්න මේ space එකේ vibrate වෙවි තියෙන්නේ. So at one instance it is here, at another instance it comes like in the middle, and it moves downwards, and it will come reach the other boundary, and again it will move upward, and it will continuously vibrate like this. Okay. So the thing is, when one particle is here, then all the other particles in that wave should be at their maximum heights. කියන්නේ මේකේ තියෙන ඉතුරු particles ටික තියෙන wave එකේ. ඒතර මේ එකක් උඩ තියෙනවා කියලා හොයාගත්තොත් standing wave එක නම් අනිවාර්යයෙන්ම nearby particles උත් ඒගොල්ලන්ගේ ඉන්න පුළුවන් maximum level එකේ තමයි ඉන්නේ. එක එක particles වල maximum amplitude එක වෙනස්. මේ මුල ඉන්න කෙනා තමයි maximum amplitude එක අපි කියනවා යට antinode lag කියලා. මේ මේගොල්ලන්ට මේ amplitude එකක් ඇත්තෙත් නෑ. අපිට කියනවා nodes කියලා. Remember, if you find some particle at a boundary, then all the other particles also should be at the same boundary. When you consider a single loop, consider when you consider the other loop, the consecutive loop, that should be the opposite. If the previous particles are at the upward boundary, then the next loop particle should be at the downward boundary. හරිද? මේගොල්ලෝ ඉන්නවා අනිත් කඩේ පල්ලෙහා ඉන්නේ. ඒතර අපි කියනවා there is a 180 degrees phase difference delta phi between two loops. Loops දෙකේ ඉන්න particles අතර 180 degrees phase difference යනවා. අපි කියනවා opposite phase එකේ ඉන්නේ කියලා. මැදදී මොකද්ද වෙන්නේ? දැන් හිතමු අපි මේ particle එක මම consider කරපු particle එක මෙහෙම යනවා කියලා. මේ වගේ තමයි දාන්නේ. එතකොට ඉතින් අර ඒ line එක දිගේ තමයි ඉතුරු particle ටිකක් තියෙන්නේ. හරිද? ඒ කියන්නේ ඒ point එක කරා line එකක් කරන දැන්තොත් ඉතුරු particles මේවත් ඇවිල්ලා දිනවා මෙහෙම. ඕක තමයි මේ standing wave එකක් වැඩ කරන්නේ. Like we showed some animations of this, how this standing wave work in the theory class. So if any student want to like revise it, you can just search in YouTube animation of a standing wave and you can find it how this particle motion happened. Okay, so let's consider the statements. A, the frequency of each vibrating particle is same. Yes, all these particles are vibrating at the same frequency. Okay, that's fine, that's correct. B, no transmission of energy to either side of the wave. So if it is a standing wave, that means the energy is not transferred. Energy just kind of like stored in a certain region. Energy like vibratory region එකේ තියෙන එක විතරයි වෙන්නේ. That's also all the particle on between two consecutive nodes are in all the particles in between in between two consecutive nodes are in phase. Okay, so nodes දෙකක් අතර තියෙන loop එකක් නේ. so loop එකක තියෙන particles මම කිව්වා දැන් එකක් උඩ ඉන්නවා නම් අනිත් එකත් උඩම තමයි ඉන්නේ. අර අපි ඒකට කියනවා in phase ඉන්නවා කියලා. හරිද? බයි consecutive loop දෙකක් ගත්තොත් එකක කට්ටිය උඩ ඉඳි අනිත් කට්ටිය පල්ලෙහා ඉන්නේ. අන්න loops දෙකකට යනකොට consecutive loops දෙකක් consider කරද්දී 180 degrees phase change එකක් තියෙනවා. but in the same loop එකම loop එකේ ඉන්න කට්ටියගේ same phase. හරිද? in phase කියලා කියන්නේ same phase කියන එකට. That's also correct then. So all three are correct, then the answer is the fifth one. Okay, 25th. One loop is taken out from a soap solution. Soap membrane can be seen. A loop made out of 6.28 centimeter length thread is kept slowly over the mentioned soap membrane. Later, using a needle, the soap membrane is pinned. Then the loop made by the thread is taken a circular shape. If the surface tension of the soap solution is 0.03 Newton per meter, what is the tension of the thread? So like this. So there is a wire loop. So in the middle, they have formed the soap membrane, soap film එකක්. Typical question in surface tension. Then they have placed a thread like this. ඔක තියලා මේ මැද තියෙන film එක බිඳලා තියෙන්නේ. හරිද? They have broken the film inside the thread. So then what happens is once this middle film is broken, ටික අයින් කරාම මේක මෙහෙම තියෙන්නේ නැහැ. හරිද? මේ තියෙන thread එක arrange වෙනවා circular shape එකක. That's because of the surface tension forces. So they are asking to calculate the surface, the tension of this wire or the tension of this thread. So tension එක හොයන්නේ කොහමද? We have done this in the class. Uh, what you have to do is consider the half of this thread. Half එක equilibrium consider කරන්න. So how the equilibrium happens? So you see, the surface tension forces are there. They are acting perpendicular to the length of the thread, like this, and in all these directions. So when you consider the resultant, or maybe මේ surface tension forces වල resultant එක බලන්න. If you remember, what we did was, so if you මේක මේ හැම force එකක්ම resolute කරගත්තොත් vertical and horizontal විදියට, you should understand these vertical forces coming from the upper half. මේ upper half එකෙන් එන vertical forces ටික down half එකෙන් එන downward vertical components වලට කැපිලා යනවානේ. And the resultant, the final resultant will be something horizontal. So this resultant can be found considering the projected length or the length perpendicular to the resultant. එහෙනම් අපිට ඔය තියෙන resultant එකේ value එක හොයන්න පුළුවන්. මේ තියෙන thread එකේ projected length එක හොයලා. projected length කියලා කියන්නේ දැන් මෙහෙන් torch එකක් වගේ ගහුවොත් හරි මේ තියෙන circle loop එකේ මේ මෙතන වැද මේ distance වෙනවනේ. මේක diameter එක සමානයි. projected length වෙන හදන්න පුළුවන්. So how to find that? FR you can find surface tension coefficient times the projected length. Projected length is 2 times r. But is it only ඒක විතරද? හරි. නැහැ මේක soft film එකක් හින්දා නම් film එකක් නම් ඒ කියන්නේ දෙපැත්තෙන්ම surface tension forces එනවා. So when you are doing the questions with films, you have to consider surface tension forces acting on both surfaces. හරිද? For surface of the lower surface. So total force is 2 times this. Okay. So 2t into 2r is 40r. So this is the total surface tension force. So it's equal to. So the surface tension value is given. And the radius they have not given. But still the total length of this thread is given. මේ length එක total length එක දීලා තියෙනවානේ. So what is total length? Total length is the circumference. Circumference is equal to 5r. So you can calculate r just by doing a simple math. So C circumference is the length, which is 6.28. You know, phi is 3.14. So these two will cancel, and you get the radius as 1 centimeter, which is 1 into the power minus 2. So once you do the calculation, you will find this is 12 into 10 to the power minus 4 Newton. But this is not what they have asked. They have not asked about the resultant force, but they have asked the tension. So if I take the tension of this string is T, the string tension is T කියලා ගත්තොත්, when the equilibrium is considered, equilibrium consider කරාම this 2T should be equal to හරිද මේකේ tension එක වගේ දෙකක් තියෙනවා දෙපැත්තෙන්. 2T should be equal to 12 into the power minus 14. Then tension is equal to 6 into the power minus 4. So which is the third answer. So let's take a quick interval, like 5 minutes, and then we will discuss the structure disease question as well as one of the essays. And as the time permits, we will try to conclude the paper as well. So if you have any questions up to this point, we have discussed 20 MCQs. So if you have any questions regarding things that which I said, as well as the things given in the marking, you can raise them now. start discussing this basic question, this paper. So this fractional essay is basically focused on mechanics practical, which is using principle of flotation to calculate the density of a liquid. Then some concepts we develop. Also the practical, we develop the concept used in the practical. Further, how uh, how to use it for a hydrometer. Like hydrometer එක තියෙන same concept එක. So ඒකට අපි practical එක කතා කරලා hydrometer ගන්න අපි theory එක develop කරන්නේ. Okay, so the question initially asked about the hydrometer. Okay, so let me explain the hydrometer real quick, and then we will see the answers. Let's go through the answers. So hydrometer is a device which is used to find the density of different liquids. So how to use the hydrometer? Like this. So how do you use the hydrometer? It's simple. What you can do is you have to fill the liquid into a vessel, and then you have to put this hydrometer down. So when you put the hydrometer into the liquid, it will show some reading here according to the displaced liquid volume. It will show some reading here. So by taking the reading, you can determine the density of the liquid. So you use the hydrometer. So in a hydrometer, there are three important parts. First one is the stem. So stem is the part on which the scale is calibrated. Make it scale like the hard. So the density values are marked on this scale. And there's the buoyancy bulb. This higher volume මෙතන මේ අර නිකන් ලිප්පිලා වගේ තියෙන volume එක අපි කියනවා buoyancy bulb. Then in the bottom there's the gravity beam. Just remember these names. Sometimes they ask these names. Okay. So these three parts are there for some specific purpose. හරිද? නිකන් නෙමෙයි. පොතක් හදලා තියෙන්නේ ඒකේ purpose එකක් තියෙනවා. So first one, we will talk from the bottom. This gravity bulb. Here, this gravity bulb. If you have seen hydrometer, this is called the hydrometer. So if you have seen a hydrometer, you will see inside this gravity bulb there are some, maybe there is some mercury or some like lead shots. නිකන් බෝල වගේ තියෙනවා. නැත්නම් මේක mercury වගේ fill කරලා තියෙනවා. That means mass here is somewhat high. The mass of the hydrometer inside this gravity bulb is somewhat high. So gravity bulb is there for some specific reason again. The purpose of this is, you may remember in hydrostatics we talked a concept like this. So if there is a object flowing in a liquid, floating in a liquid, liquid දෙක මොකක් හරි object එකක් float කරනවා නම් අපි කියනවා මේ තියෙන object එකට වඩා stably flow වෙන්න පුළුවන්. How? If its center of gravity acts below the center of buoyancy. අපි කියනවා මේක stable flow කරන්න පුළුවන් center of buoyancy. Center of buoyancy කියලා කියන්නේ අර across force එක ඇති වෙන point එක. හරිද? දැන් අපි දන්නවා මේක float කරාන් පස්සේ මෙයා මෙතන ඉන්නේ across force එකයි weight එකයි balance කරගෙනනේ. Yes. Thrust is balancing the weight. So the thrust is acting from the buoyancy center. Buoyancy center කියන්නේ nothing මේක අර බොයින් සෙන්ටර් කියලා කියන්නේ ඩිස්ප්ලේස් වෙලා තියෙන ලික්විඩ් වොලියම් එකේ සෙන්ටර් ඔෆ් ග්‍රැවිටි එක. කියන්නේ මේ තියෙන ලික්විඩ් වොලියම් එක තියෙනවානේ. ඒතර මෙතන මේ වොලියම් එකට දාලා සෙන්ටර් ඔෆ් ග්‍රැවිටි ගත්තොත් ඒක තමයි බෝයන්සි සෙන්ටර් කියලා කියන්නේ. ඒක බෝයන්සි සෙන්ටර් එකට වඩා යටින් මේ තියෙන ඔබ්ජෙක්ට් එකේ සෙන්ටර් ඔෆ් ග්‍රැවිටි එක තියෙනවා නම් දැන් එතකොට අපි කියනවා මේක ස්ටේබල් කියලා. ෆ්ලෝට් වෙන එක. ඇයි? හේතුව තමයි ඔයා මේක හිතන්න පැත්තකට පොඩ්ඩක් මෙහෙම ඉන්ක්ලිනේෂන් එකක් දුන්නොත් කියලා හරිද? එතකොට බෝයන් සෙන්ටර් එක නිකන් මේ වගේ වෙයි. mg මේ වගේ වෙනවනේ. weight එක. first එක මෙහෙම. What happens? If you lean this to one side, මේකට නිකන් පොඩ්ඩක් මෙහෙම වැඩ කළොත් you see මේ තියෙන forces දෙක equal in magnitude and opposite in direction. හරිද? මේ දෙන්න equal හැබැයි direction එක වෙනස්නේ. and actions මේ line of action එකත් වෙනස්. මෙහෙම දෙනවා අපි කියනවා couple of force එකක් එනවා. moment එකක් ඇති වෙනවා. මේ moment එක එන්නේ කොහෙටද? If you lean to this side, the moment will be to the opposite direction. So what happens is, so if because of some reason, if this object leans to one side, then there will be moments develop such that it will be taken to its original position using those moments. ඒ කියන්නේ අන්තර restoring moment එක කියනවා restoring moment කියලා. හරිද? ඒ restoring moment එක ඇවිල්ලා මේක ආයි යාගේ original position එකට ගේනවා. ඕක තමයි මේ center of gravity එක පල්ලෙහා තියෙන එකේ වාසිය. හරිද? ඔන්න ඔය වාසිය ගන්න ඕන කම තමයි මේ පල්ලෙහාට අපි මේ මෙයාගේ වැඩිපුර masses දාලා ඒතර එයාගේ purpose එක තමයි center of gravity එක පල්ලෙහාට ගේන එක. එහෙනම් gravity bulb is there to lower the center of gravity of this hydrometer to float it stably in vertical way inside a liquid. හරිද? ඒතර මේ gravity bulb එක තියෙන්නේ center of gravity පල්ලෙහාට ගෙනල්ලා මේක vertical way එකේ stably float කරගන්න. මේක liquid එකට දැම්මම hydrometer එකෙත් වෙන්නේ ඔච්චරම තමයි. හරිද? මෙහෙම යමක් හරි liquid volume එකක් නෙවෙයි volume එක displace කරනවා. ඒතර ඔය volume එක displace කරාම ඒකෙන් එන upthrust එකයි මෙයාගේ weight එකයි balance වෙනවා. ඒ වෙලාවෙ තමයි අපි ring එක ගන්නෙ. ඒතර අර center of gravity එක පල්ලෙහාට ගත්තාම එතකොට මේක පොඩ්ඩක් පැත්තකට යනකොටත් එහෙම ආයිත් restoring moment එකක් ඇවිල්ලා අයියාගේ original vertical position එකට යනවා. හරි. So that is the purpose of this having this gravity bulb. Taking the center of gravity low to a lower position. And buoyancy bulb, what is it is used for? Why it is used for? The buoyancy bulb. Remember, the buoyancy bulb is used to displace higher volumes of liquid. Buoyancy bulb එක use කරන්නේ higher liquid volumes මේකේ displace කරන්න. ඒක වාසිය මොකක්ද? අපි මේ displace කරන්න පුළුවන් liquid volume එක වැඩි කරගත්තාම අපිට පුළුවන් මේ තියෙන hydrometer එක low density liquids වල උන density එක හොයන්න use කරන්න. We can use this hydrometer even to calculate or the measure the density of low density liquids as well. If you have this buoyancy bulb, then it can displace like a considerable amount of volume inside this buoyancy bulb, and then it can float in a low density liquid as well. buoyancy bulb එකකින් එන volume එක කියන්නේ මේ higher volume එක displace කරගෙන යාර පුළුවන් low density liquid එකක උනත් up වෙන්න. So that is the purpose of this buoyancy bulb. And finally the stem. So stem is there to get this density scale calibrated. හරිද? density scale එක calibrate කරන්නේ stem එකේ. And when you are making the stem, it is important that this stem has a lower cross section. මේකට cross section එක මෙයාගේ අඩු වෙන්න ඕනේ. Why it is important? ඒකට හේතුව තමයි when you lower the cross section of a hydrometer, then its sensitivity increase. Sensitivity increase. මොකක්ද කියන්නේ? ඒ කියන්නේ මේකයි. හරිද? මම ඔයාලට කිව්වනේ මේක වැඩ කරන්නේ simple principle එක thrust එක mg ට equal වෙලා කියලා. thrust එක අපි equationally work. thrust එක equationally work. මම ගන්නම් මේ තියෙන මේ පල්ලෙහා තියෙන total section එකේ total වොලියුම් එක V කියලා. හරිද? ඊට පස්සේ මෙන්න මේක දිගේ මේකේ ක්‍රොස් සෙක්ෂන් එක මම A කියලා ගන්නවා. and මේකේ ගිරලා තියෙන length එක මම L කියලා ගන්නවා. එතකොට මේකේ total displaced volume එක වෙන්නේ පල්ලෙහාම තියෙන total volume එකයි ඊට පස්සේ අර stem එකේ immense වෙලා තියෙන part එකයි මෙන්න මේකයිනේ. මේක AL. ඒකේ volume එක AL. equal වෙන්න ඕනේ mg. ඕකනේ වෙන්නේ. So the advantage is this. So yes. ඉතින් මේක multiply වෙන්න ඕනේ density of a liquid times G. So the advantage is this. Okay, මම මෙයාව subject කරනවා. You see, if you have a higher, sorry, if you have a lower area, if you have a lower cross section area, අපි තමයි මොන එකම liquid එකේ hydrometers දෙකක් ගිල්ලනවා. මේ hydrometers දෙකේ කිසිම වෙනසක් නැහැ. weights හැම එකකම සමානයි. හැබැයි අපි තමයි එකක cross section එක වැඩි. මෙයාගේ cross section එක වැඩි. අනිත් කෙනාගේ අඩුයි. උතන තියෙන වාසිය තමයි when the cross section area is lower. මේ equation එක තාම valid වෙන්න ඕනේ. මේ හැම එකක්ම constant කියලා මම කියවනේ. එකම liquid එකේ ගිල්ලලා තියෙන. ඒතර constant. ඊට පස්සේ එකම එක දෙන්නේ. එහා part එකත් same. මේ කියන constant. වාසිය තමයි the lower the cross section, the higher the length මේකේ submerged in the stem. මේ stem එකේ අර ගිල්ලලා තියෙන length එක වැඩි වෙන්නේ cross section එක අඩු වෙනවා. ඕක ඇත්තටම වාසිය තියෙන ඕකෙත් නෙමෙයි. හරිද? අපි හිතමු දැන් ඔන්න මේ තියෙන එක liquid එකකනේ. අපි හිතමු පොඩ්ඩක් density එක වෙනස් වෙනවා කියලා. ඒතර නිකන් අපි හිතමු ඒතර ආයිත් equation එන්න ඕනේ මෙන්න මෙහෙමයි. හරි density එක වෙනස් වුණොත් වා වෙන liquid එකකට ගිහින් දැම්මොත් ওই ගිල්ලලා තියෙන length එක පොඩ්ඩක් වෙනස් වෙන්න ඕනේ. delta L කියනවා length එක පොඩ්ඩක් වෙනස් වෙන්න ඕනේ. ඒක equal වෙන්න ඕනේ. මේ පැත්තේ කියන මොකක් හරි delta value එකකට. හරි. ඉතින් මේ side එකේ මොකක්ද වෙනසක් කරන්නේ? density එක වෙනස් වෙනවා ගමන් මෙතන වෙනස් වෙනවා. එතන වෙනස් වුණාම මේක තිබ්බ value එක වෙනස් වෙනවා. ඒ වෙනස් වෙන value එක අපි delta k කියලා ගමු. හරි. එතන මේකේ අර මෙන්න මේක තමයි හරියම advantage එක. once this A decreases and A අඩුවෙද්දී ඔයාට density එකේ වෙන වෙනසක් මේ delta k එකේ ඉන්නේ density එක වෙනස් වෙන හින්දා. හරි. ඒකට ඒ අඩුවෙද්දී one density එකේ එන වෙනසක් වැඩි length එකකින් පෙන්න ගන්න. ඒතර density එකේ වෙනස වැඩි length එකකින් පෙන්න ගන්න පුළුවන් කියලා කියන්නේ අපි කියනවා මේ ඒ දින measuring instrument එක පොඩ්ඩක් sensitive. මේ කියන්නේ හිතමු liquids දෙකක් තියෙනවා. එකක density එක 1000 kilogram cubic meter අනිත් එක 1002 කියලා. 1000 වලදී මොකක් රේට් එකක් වෙනවනේ. හිතමු L1 කියලා. ඒක cross section එක පොඩි වෙන තරමට. cross section එක පොඩි වෙන තරමට. ඔයා ඊළඟ එකේ හරි මේ ඊළඟ liquid එකේ මේ ගිල්ලුවාම මෙතන තියෙන වෙනස හරිද මේ කලින් තිබ්බ level එක මේක නම් එතකොට මේ scale එකේ වෙන වෙනස ටිකක් ලොකු value එකකින් ගන්න පුළුවන්. මට cross section එක දුන්නා. ඔය පෙන්වන readings දෙක අතර වෙනස ටිකක් ලොකු වගේකින් ගන්න. ඒතර ලොකු වගේකින් ගන්න එකේ වාසිය. මෙහෙම ලොකු value එකකින් ගන්න එකේ වාසිය තමයි එතන අපිට කියව ගන්න ලේසි. දැන් 1000 කියන එක මෙතන තිබිලා 1002 එක මෙන්න මේ හරිය වගේ තියෙනකොට වරුණ 1001 එක උනත් හදා ගන්න පුළුවන්. ඒ වගේම උනේ 1000.5 කියන එක උනත් හදා ගන්න පුළුවන් යන මේ length gap එක වැඩි වෙනවා තමයි. ඕකට තමයි අපි කියන්නේ sensitivity එක වැඩි වෙනවා. ඒතර sensitivity එක definition එකක් කිව්වොත් sensitivity කියන එකට මෙතනදී මම definition එකක් කිව්වොත් මේක මට කියන්න පුළුවන් change in length per unit increment of density. So I'm going to be delta L change in length per unit. So cross section එක පොඩි වෙන තරමට change in length per unit density change increment of density කියන එක වැඩි වෙනවා. sensitivity වැඩි වෙනවා. ඕක තමයි stem එක cross section අඩු වෙන එකේ වාසිය. හරිද? මම හිතනවා ඒක ක්ලියර් ඇති කියලා. ත්‍රෝග ඇතරම මේ ෆස් question එකේ ඒ පාර්ට් එකට දැන් ආන්සර්ස් ටික සේරම වගේ මම උතන කිව්වා හරිද ෆස් පාර්ට් එකේ මාක් කරන්න කියනවා මේකේ තියෙන මේන් පාර්ට්ස් තුනයි ABC කියලා ඒතර A කියන්නේ stem එක ඊට පස්සේ B කියලා කියන්නේ buoyancy bulb එක C කියලා කියන්නේ gravity bulb එක හරිද and second one write down the uses of B and C B C දෙනාගේ uses ලියන්න කියනවා ඒතර මොනවද B වල use එක තමයි buoyancy bulb එක තියෙන්නේ අර higher liquid volumes මේකේ displace කරලා lower density liquid එකක වුණත් මේක float කරගන්න පුළුවන් වෙන්න. හරිද? අපි කියන්න ඕනේ to displace higher liquid volumes enabling to float even in low density liquids. හරිද? ඔතමලගේ මාර්කින් එකේ තියෙන එක හරි. Okay. See, gravity bulb. Gravity bulb එක තියෙන්නේ to lower the center of gravity such that it can be stably float in vertical position in a liquid. අර liquid එකක අර vertical position එකේ stably තියාගන්න පුළුවන් වෙන්න center of gravity එකේ පල්ලෙහාට ගන්න එක තමයි මෙයාගේ function එක. Okay. Third one. Draw the scale on the figure to mark the densities 800, 1000 and 1200. හරි. ඔය විදිහට දෙන figure එකේ මේ scale එක mark කරන්න කියනවා ඔය 800 කියන එකයි 1000 කියන එකයි 1200 කියන එකයි එන්න ඕනේ විදිය එන විදියට. ඒතර මේකේ මේ අන්න ඒක ටිකක් පොඩ්ඩක් අලුත්. මෙහෙම තියෙන්නේ. මේක ටිකක් අලුත්. මතක තියාගන්න. Remember, the scale of a hydrometer is not a linear scale. අපිට නිකන් මේක linear scale එකක් නෙමෙයි. සාමාන්‍ය අපි ගොඩක් measurements ගන්න scales linear නේ. මේක linear නෙමෙයි. මේකේ ඔයාලට මතක නම් මෙතන දැන් අපි මේ relationship එක ලියද්දී බලන්න මේ දෙන්න අතර තියෙන නිකන් අර product එකක් නේ. නැත්නම් මේ මොනවද තියෙන්නේ? මේ ඊටු සේරම constant කියලා හිතුවොත් මෙතන අතර L dot rho කියන එක constant. ඒතරෝනි පේන්න ඕනේ මේකේ අර submerge වෙන part එකේ submerge වෙන stem part එකේ length එක සහ density එක අතර තියෙන inverse proportion එකක්. හරිද? There's an inverse proportion. So it means inverse proportion of the density. එහෙමම මෙතනදී මේ densities mark කරන විදිය පොඩ්ඩක් වෙනස්. හරිද? So here stepping බලමු. It's what I got stepwise. First thing to understand is the higher the density, the lower the length which is submerged. Higher the density, lower the length submerged. ඒක තේරුම් ගන්න. density එක වැඩි වෙන තරම මේකේ ගිලන ප්‍රමාණය අඩුයි. ස්ටෙමිටි ඩේටා ප්‍රමාණය අඩුයි. ඒ කියන්නේ මේ well density කියන ඒවා calibrate කොහෙන්ද? If the density is higher, then high density should be very low, should be lower. You can scale එකේ පල්ලෙහෙන් තමයි high density එන්නේ. පල්ලෙහා තමයි high density එන්නේ. So the opposite of it, if the density is lower, the length is higher, given ප්‍රමාණය වැඩි, that means low density liquid should be the part තියෙන්නේ උඩ ඉනම් පල්ලෙහාට තමයි මේක වැඩි වෙන්නේ. උඩ අඩු වේවා පල්ලෙහා වැඩි වෙනවා. Then another thing, we said this scale is not a linear one. There is the indirect proportion. So the length versus density curve. If you get a curve, it should be like this. So these density values we have given density values with equal gaps. Density values 0 in equal gap. 800, 1000, 1200. So when considering this is 800, I'm gonna make 800 kilo, and this is 1000. This is 1200. So what should be the length gaps between these marks? You see. So if this is the variation, then at 800 density, the length submerged should be something like this. මේ හරියට වගේ තමයි length එක මේ උඩ ගිල්ල තියෙන්න ඕනේ. And then for 1000, the length should be something like this, L2. And for 1200, the length should be like this. Length. So බලන්න මේ submerged ලා තියෙන length අතර gap එක. Here between 800 and 1000, the gap is high, but between 1000 and 200, the gap is not that high. It's lower. So that's why we call this is not, this is not a linear scale. හරි. ඒක විදිහ තමයි මේ කියන්නේ මේක linear scale එකක් නෙමෙයි කියලා. So 800 කියන එක මේ හරියට mark වෙයි. If you mark 800 somewhere here, and if you mark 1200 somewhere here, that's not a problem. ඒක වලට කැමතියි mark කරන්න පුළුවන් වෙනවා. But when you marking the position for the 1000 කියන ගණන position mark කරද්දී, that should be more closer to the 1200 mark. L3 කියන එකට closer වෙන්න. That means this upper gap should be high. That's what you mean by the not being the scale linear. Scale එක linear වෙන්නේ නැහැ කියන එක නෙවෙයි. Delta L1 L2 1 2 3 එක මේ තියෙන්නේ delta 2 3. මේ ඔබ හරියට මාක් කරලා දෙනවා නැත්නම් ඔයාලට මාක්ස් හම්බෙන්නේ නැහැ. So if you want, you can make a note of it. Then lastly, mention the reason for making a section a narrow tube. So I mentioned the reason. A is made narrow, or the cross section is made lower to make or to increase the sensitivity. So increasing sensitivity means a small change in density. A small change in density can be like measured with a higher gap of length. And length එකේ higher gap එකකින් මට density change එකක් eco density change එකක් ගන්න පුළුවන් sensitivity වලින්. එහෙම නම් අපිට අඳුර ගන්න ලේසි. cross section එක පොඩි වෙන තරමට වැඩි length එකකින් eco density change එක ගන්න පුළුවන්. Okay. Once again, to increase the sensitivity of the hygrometer, or else to have the higher length change respect to a lower density change. Okay, so that's it about A. If you have any question, please mention. So I'm going to continue. So if you want to take notes, you can like pause the video after this session and take these sensitivity calculations here. Yes, Karan. Okay, B. An experiment is planned to find the density of a liquid using a boiling tube. So this is the article which is in your guide. So there, what we do is we're gonna vertically float a boiling tube with some mass units inside it, and calculate the density using length gradient that we can select. Massive distance සම්පූර්ණ length එක මම ගන්න විවාහ factor density එක ගන්න කරන්නේ. Okay, so they have given some parameters or variables. The volume of the weighted portion. Weighted portion means this portion. So the volume of this is capital V. The mass of the boiling tube with the weighted section. volume tube එකයි weighted section area total length. The cross section area is really this is a section as simple M. So I said we're gonna add some masses. Sort of using mass units, we're gonna add some masses. So the added mass is simple M. Using the mass units, the added mass is simple M. Okay. So the added mass is simple. And there is the scale used to take the length measurement. Kita මේ තියෙන්නේ scale එක තමයි මේකෙන් තමයි මේ length measurements ගන්න. අර 0 එක මෙන්න මෙතන විදිහට අරන් තියෙන්නේ. So if the 0 is here, you can measure the length here using this scale. මේ length එක බලන්න පුළුවන්. So it's given. The length of the submerged section is L. And the density of the liquid is rho. So these are the given terms. So first one. So part 1. Write an expression for the submerged volume of the boiling tube. Okay, they are asking to write an expression for the submerged volume. That means this total volume. Submerged is total volume. So how to write the expression? So here, this weighted section volume is B, that's given, and the submerged length is given, and the cross section is given. So the total volume submerged is this volume plus this cylindrical volume. So the cylindrical volume you can calculate by multiplying the cross section using the submerged length. Simple. Then write an expression for the weight of the boiling tube. Okay. So the weight, how to write an expression? Again, they have given the empty mass of the boiling tube and the weighted portion. Mass units down calling mass capital M kilo, and the mass of the mass units is also given. So the total weight, if I take the weight as W, then the total weight should be equal to total mass times the weight. Weight and mass are two different concepts. When mass multiplied by the gravitational acceleration, only you get the weight. Okay, third one. Find an expression for the upthrust force acting on the boiling tube. Okay, upthrust force, you know, the upthrust is given by the displaced volume into the density of the liquid into G. So what's the displaced volume? Here the total volume displaced is, you have already found, equal to L rho G. That's how you think the upthrust. So not a big deal. Fourth one, rearrange the expression in 4 to plot the graph to find the density of the liquid. So the whole purpose of doing this practical is to calculate the density. Density quantity. So how to determine the density? What we do is we're gonna take an equation, consider the equilibrium, and we're gonna rearrange the equation such that a linear graph is obtained. Linear graph rearrange. And then using the graph, I'm going to calculate the density. That's the normal procedure what we do. So let's try to build up a relation. So when consider this equilibrium, consider karama, this upthrust force should be equal to the total weight. So upthrust, you got an expression. Total weight also you got an expression. Okay. So when these values are cancelled, you can obtain linear relationship to plot the graph. Again, there is another thing that I should mention. So in this practical, what do I change and what do I observe the change? වෙනස් කරන්නේ සහ මොකක්ද වෙනස් වෙන්නේ? දැන් මම graph එකක් ගම ගන්නවා නම් වෙනස් කරන්න කෙනෙක් ඉන්න ඕනේ. ඒක වෙනස් කරද්දී වෙනස් වෙන්න කෙනෙක් ඉන්න ඕනේ. So the quantity which I change is the number of mass units. And the mass added using the mass unit is the thing which I am going to change. මම වෙනස් කරන්නේ simple m. So simple m is the independent variable. I'm using different masses and observe the behavior or the observe this length submerged inside the liquid. So m is the independent variable. L, L is the dependent variable, submerged length. Okay, so if this is the dependent variable, then we should take it to the y-axis. So we have to find a way to rearrange the graph such that the dependent variable comes to the y-axis. So I'm gonna like subject this simple L. So how to subject it? Simple. Uh, B plus AL is equal to M plus simple M divided by rho. So if I subject L and rearrange the equation, L should be equal to, okay, L should be equal to C. So this is the equation. This is the form of equation which I make rearrange karama dependent independent yeah හරිද dependent කෙනා relationship. So if I take this, so let me write the relationship here. N is equal to 1 over 0, it's n over a rho minus e over a. So this is what I get. So if I take this to the y-axis, and if I take this as x-axis, you can see this whole thing will be a straight line. Variation will be a straight line because cross section එක වෙනස් වෙන නෙමෙයි, density එකත් වෙනස් වෙන්නේ නැහැ intermediate cases වලදී. And all these capital M also does not change. B also does not change. So this thing is a constant, and here it is a constant. So if you change M, L is affected. How? Y equal mx plus c. In a behavior like y equal mx plus c. So the graph should look like a straight line with a positive gradient. Positive. Okay. So for the fourth part, okay, this is the fifth part. We have done both parts here. So obtaining the relationship. So for the fourth part එක මෙතන තිබුණේ නැති. මෙතන තිබුණේ නැති. Fourth part එක නතුනට තිබුණේ නැති. For the fifth part, they are asked to rearrange the expression in 4 to plot the graph to find the density of the liquid. ඒක තමයි ඊට පස්සේ මේක dependent independent බෙදලා relationship ගන්න. So for the fifth part, this is the answer. Okay. So draw the shape of the graph. Okay, so mention the axis. On make axis දෙක හරියට mention කරන්න then label කරලා නැහැ. So this should be the length, submerged length, and this is the added mass using mass units. So mass units දාලා mass එක. So you should have a sketch like this. A graph, a straight line with a positive intercept and a positive gradient. Okay, so the sixth, so eighth such part. Next one, what are the additional measurements that need to be taken to find the density of the liquid? So how to calculate the density? So in this relationship, where you find the density? You find the density in two places. First one in the intercept also you can find, but most importantly, you can find in the gradient. Gradient again. So when the gradient is considered, is the length. There are terms that are so it is the best way to calculate the density. So what is the other required measure to calculate the density? So basically the density is calculated by the gradient. Gradient density. So gradient is equal to 1 over a rho. So the density you can calculate just OG. Say OG. Okay. cross section area times G. So what do you read? How come over it? So to calculate the density, you need uh, cross section area. How to make a gradient and cross section area go on it. So how to calculate the cross section area? Here, this cross section area is the outer cross section area. So calculate the outer cross section area. What do you need? You need either the radius or the diameter. But remember, in measurements, you can measure the radius. Radius is measure from center. So the only thing you can measure is the diameter. Okay, diameter is the one which can be measured. So then to evaluate this cross section area, you will need the diameter. So what's the answer? You will need the external diameter. External mean, if you write the mean, that's much better. If external is only enough, external diameter of the boiling tube. This external term should be there. Huh? Otherwise, you will not get any marks. External diameter of the boiling tube. That's what you need. Okay. Last part. Write an expression for the density of the liquid using the product graph. So, okay, that part I have already done. Density formula again. So you see, gradient is equal to 1 over rho here in this relationship. This is the gradient. So gradient is equal to 1 over rho. So then density is equal to 1 over Ag. So when you use, like, let's say this mean diameter is D, D කියලා ගන්නවා මෙයා. නැත්නම් මේක දෙන්න. Easy here. This one is let's subtract this gradient from here. So here capital D is the gradient. This is it. So let's quickly discuss this gravitational problem and then finish today's discussion. Read the question. This paper is not that hard like previous one, the revision paper one. Still, there's another paper. So after discussing this paper, I'll upload the user paper 2 as well to the group. So the students can cover the booster paper 2 within the next 2 weeks. Like the next week, there will be only a revision paper. So you don't get any homework. So only the work related to that paper is there for next week. So within this week and the next week, you have to cover this revision paper 2. Okay. So second question. Okay. A satellite of mass simple m is orbiting around Earth in orbit with radius simple r. Motion of a satellite. So this is Earth. Mass is given capital M, and this satellite mass is simple m. Orbiting. Orbiting means moving in a circular motion. The orbital radius is given. Orbital radius. When you say the orbital radius, it is measured from where? It is measured from the center. Orbital radius from center in the measure කරන්නේ. First, so part. If the gravitational acceleration on Earth's surface is g, show that gm equal gr squared. Here this capital R is the radius of the Earth. Earth radius. So this is a very common thing for gravitational field questions. So if the so we know the gravitational acceleration is given by this formula. Okay, the gravitational acceleration at a certain point is given by gm over r square. So capital M is the mass of Earth. R is the distance from the Earth. So when you consider the surface එක point එකක් ගත්තාම surface එකේ distance වෙන්නේ radius එකනේ. So g should be equal to gm over capital R square. So G capital M is equal to simple G. So it's second, extract the orbital velocity of the satellite in terms of G capital R and simple R. Orbital velocity ka කියන කියනවා capital R simple R and the G වල term විදියට. So consider the circular motion. So you all know to perform a circular motion there should be a centripetal force. So in this case the centripetal force is given by gravity, gravitation force. So make it equal. So the gravitation force is equal to the centripetal force. So centripetal force you can write mv squared over the radius of the circle, isn't it? So අපි class එක යන කන්නේ center එක this direction එක equal වෙනවා. So the force is Fg and the acceleration is equal both way fine. Reaction force is G capital M simple M over 1 square. This is given by the Newton's second law. Simple thing equal to simple M mass of the satellite v squared over r. So 1 r get cancelled, simple M also get cancelled. You get the velocity is equal to square root G capital M over simple r. Now the problem is you can't keep capital M here. They are asking the formula in terms of simple G and capital R. So what you can do? So earlier in the first part you found Gm product is equal to Gr square. So replace it. You can replace it. So velocity is equal to G capital R square divided by simple R. See that writing here? Discipline. So part A is fine. Okay. Spacelab is in circular orbit of 1,700 km above the Earth's surface. This is Spacelab is 1,700 kilometers above Earth's surface. Okay, the distance is given from the Earth's surface. What is the speed of the speed lamp? Spacelab. The radius is given. The gravitational acceleration also given. Okay. Okay, so we can find it. If the velocity is v, v is given by square root g last square simple simple. That's what we got in the earlier calculation. Substitute values. G is 10. These are the particular radius of the Earth 6,400. They have given it. But it is in kilometers. So you have to make it meters. Huh? In kilometers meters karana 10 to the power 3 multiply karana. Squared divided by the radius, the distance from here to the orbit. So remember, they have only given this distance from the surface to the orbit, not what we need. The only make it. So that is the sum of both the radius and the distance from the surface. If you R කියලා කියන්නේ යාගේ radius එකයි ඊට පස්සේ මේ තියෙන distance. So this is 6,400 plus 1,700 into 10 to the power 3. Okay, so what do you get? So if you solve this, I think you should get the given answer. So I'm just going to write it. So we are running okay. This is it. So when you are doing like this kind of essay question, make sure like when you're solving this kind of problem, first you have to do the substitution very clearly. මේ substitution එක කරන්න ඕනේ හරියට. You will get some marks for this step. හරියට S මේ units convert කරලා substitution එක කරලා දෙනවනේ marks හම්බ වෙනවා. So this step should be there, and you will get the other marks. I mean, most of the highest number of marks for a certain subsection for the final answer. Final answer තමයි minimum ගණක් තියෙන්නේ, but there should be a method that this comma මේක එන විදියක් තියෙනවා. විදියක් තමයි සාමාන්‍යයෙන් full marks හම්බෙන්නේ නැහැ. So this part and this. So be careful on these two. Okay, so was this that? Second part, calculate the minimum energy that has to be supplied to the space vehicle of mass 10 to the power 4 kilogram, including cargo, to just reach the orbit of the space lab from neglect the air resistance. So minimum energy. Frequently talking concept in gravitational field, if you talk about energy. So what's the minimum energy? If you reach the orbit from Earth's surface, the minimum energy required should be what? It should be the increase in potential energy. Simple. So to travel from Earth's surface to this orbit, the minimum energy required is this increase in potential energy. Remember it. Work mean required minimum work is increase in potential energy. So how to calculate the increase in potential energy? Obviously, you know, when you like go up from the surface again order and order, higher you go, higher your potential energy will be. Energy. So to calculate the increase in potential energy, you have to subtract the get the difference between the potential energies of the orbit and the surface. So how should the formula look like? Work minimum should be equal to the orbit potential energy is minus the capital M simple M over the distance to the orbit. Or else you can write r plus x because the height is mentioned in mention කරලා දෙන්නේ height එකනේ. ඒතර radius එක කියලා කියන්නේ r plus simple h minus the minus sign in this equation. The potential energy on the surface. On the surface එකේ potential energy minus dm divided by capital. Okay, so this minus minus will be plus. So I can take g capital M simple M out. It will be 1 over h. Again, mass is not given. I mean, Earth's mass is not given. So you have to replace this dm with gr squared. Here we will show these two are equal. So g capital R squared simple M 1 over 3.1 meter h. Here h again all of that cancel. Now you can substitute units. So g is 10, radius is 6,400, but you have to make it meters multiplying by 10 to the power 3, and there's a square, and then the mass carried. The mass carried from Earth's surface to this orbit is given 10 to the power 4. The mass carried is 10 to the power 4 times the height. Height from the surface is 1,700 to the power 3 divided by 6,400 times 6,400 in plus 6,400 plus 1,700 into 10 to the power 3 into 10 to the power 3. Why? These two 10 to the power 3s are to convert these kilometers values into meters. That's the unit on it. So 10 to the power 3s are getting cancelled. And again, you can cancel another 10 to the power 3 here. 10 to the power 3 up. And so you can cancel like this. And again, these zeros also can be cancelled. So when you solve the rest, solve you will get the given answer, which is 1.34 into the power 11 joules in screen. Let's see minimum energy required. Okay, so third part. What additional energy is required for the space vehicle to link with the space lab without changing its orbit? Oh, very simple. Uh, the additional energy. Actually, we have broken these concepts very clearly in the theory class. So, if anyone want to watch this, still the YouTube video is also there. So, if any online student require to cover up this gravitational field theory, you can watch those lessons. As well as if you need to cover these practicals, most of the practical videos are also uploaded into this channel. So you can watch the videos as well. So third part. So what's the additional energy required? So you see, by the minimum energy, what it have done, and when you give the minimum energy, what happens is these masses are taken to the orbit, nothing else. When you give the minimum energy, the masses are taken to the place, I mean, to the orbit where this space lab is located. Masses are only taken there. So now, if you want to uh, like transfer uh, this, if you want connect this space vehicle to this space lab, you have to give it the same velocity of the space lab. Space lab එක මෙතන යන velocity එකක් තියෙනවා. ඒ velocity එකට මේ තියෙන space vehicle එක ගන්න බෑ. So the additional energy requirement is the increasing kinetic energy. So when you say the work minimum or the required minimum energy, it only means you are carrying the space vehicle from here to here. So when you carry the space vehicle from here to here, there will be no any kinetic energy left here. And then the kinetic energy. So to couple with the space lab, to couple or to orbit with the space lab, what you have to do is you have to give the same to the same velocity to this space vehicle as well. So to give this space vehicle, you will require some energy, that is the increasing kinetic energy. So you can calculate this increasing kinetic energy half m v orbit square. So velocity square, velocity we initially calculated. This orbital velocity we initially found. So just substitute the values. Math is about here it is 711. So you will get some value. I think the value is 2.53 to the power 11. So if you solve this, you should get this value. Okay, so that's the additional energy. And lastly, the fourth one, after the linkage, the cargo in the space vehicle is transferred to the space lab. Will the speed of the orbiting space lab change due to the loading this cargo? Explain your answer. So I'm just gonna do that as well, and then give you some time to write things on the third second one. So what do you think? So after the linkage, like here, initially by the work minimum, you just taken the space vehicle here, and then to link with the satellite, what you have done is you have given the same velocity to this space vehicle as well. minimum energy දීලා ගියාම මොකක්ද නැහැනේ. ඒතර ඒ velocity එක දෙන්න indicator දුන්නා. Then they asked, when you're transferring the masses between this vehicle and this space lab, will there be any change in speed? Speed එකේ change එකක් වෙනවද කියලා අහන්නේ. So do you think there will be any change in velocity? Let's say two cars are going at the same velocity side by side. අපි නම් cars එකක් ඔන්න එකම road දෙකක side by side ඔහම same velocity යනවා. කියන්නේ මේ car එකට relative මෙයා හැම වෙලේම අනිත් පැත්තේ අනිත් car එක තියෙනවනේ. So if like නිකන් අර සර්කස් එකක් පෙන්වන්න ඕනේ වගේ මිනිහෙක් කියනවා එයාට පුළුවන් එයාගේ එකලෙක් ගියත් මේ කාර් එක දිහායි අනිත් එකේ අනිත් කාර් එක දිහායි මෙහෙම හිට ගන්න. ප්‍රශ්නයක් නේද? මිස්ටේක් වෙන්නේ නැහැ මේ කාස් දෙක එකම වෙලෙසින් යනකම්. හරිද? හරිද? මේ කාස් දෙක එකම වෙලෙසින් යනකම් එහෙම කවුල් දිහාගෙන ඉන්න පුළුවන් නේ. ඒත් එයාට ඕන නම් පුළුවන් මේ එයාට මේ පැත්තට පයින්නත් පුළුවන් අනිත් පැත්තට පයින්නත් පුළුවන්. හැබැයි පැන්න කියලා මේගොල්ලෝ වෙලොසිටි වෙනස් වෙනවද? වෙනස් වෙන්නේ නැහැ. ඇයි ඒ? Because all of these masses are traveling at the same speed. p. මේ මිනිහත් v velocity යන ගමන් ඉන්නේ. මේ මිනිහා මෙහෙම තියාගෙන ඉන්නවා කියලා කියන්නේ මෑත් v velocity යන ගමන් ඉන්නේ. ඒ යා මෙයත් එක්ක ගියත් එකයි අනිත් එක්ක ගියත් එකයි කොහොමත් එකම momentum එක තියෙනවා. So there will no be any change in momentum. හරිද? So එතන මේ මෙතන වගේම තමයි දැන් මෙතනත් transfer කරද්දී link කරනවා කියලා කියන්නේ දෙන්නටම same velocities තියදී mass transfer කරනවා කිසිම orbit එකේ change එකක් වෙන්නේ නැහැ. Okay, so the simple answer is no. Both are traveling at the same velocity. So when moving the cargo, there cannot be any velocity change. The reason is the momentum should be conserved. The momentum is conserved in both cases. Okay, so I think we can stop here at this point. So today is like somewhat better than the previous day. So we covered the 25 MCQs as well as structured as well as an essay question. But this paper kind of like I feel like this is somewhat easier than the previous one. So I expect students to score more for this paper than the previous one. Okay, let's see when the marks come. Okay, so if you have any questions, again raise in the chat. I'll wait for a few minutes. Okay, so there are no questions for anyone. So then we can end the session at this point. So again, there is a remaining essay question to be discussed. But now there is no any. I found no enough time to complete this section. So you can go through the marking for that question. So if you don't understand any part of this question, you can get to me using WhatsApp or any other on available on Telegram as well. So you can get to me. So we can stop the session here. And again, I have remind that tomorrow there will be the recap session, which covering the center of gravity, equilibrium, and the energy concepts basically. So I think it will be more useful for you guys to revise through the uh, previous content, the initial content. Uh, and again, for the next week, for the next coming week, that will be the first week of February, we will get another revision paper, which is 3 hours and 10 minutes. So physical students can face physically, online students can face online as usual. The same answers will be there. So I have to ask you, just like be ready for the paper. Uh, Revise through content. If it is able to do, then I'll may inform in the group which parts you will be questioned in the next revision paper. So if I mention the parts, then it will be easier for you to revise them before coming to the before facing the exam. But that will happen only for few papers. Initially තියෙන papers කීපයක විතරක් මම කියන්නම් ඔය content එක මොනවද වෙන්නේ කියලා. ඒකට ඔයාලට explain පුළුවන්. Okay. So I think mostly it is also from the first 4 lessons as well as the 10th lesson. Yes, you can inform later. Okay, then we can stop here. So everyone, good night. Hope you learned something from this.